On.
All right, so today we will be talking about plate tectonics, continental drift, and how what happens at plate boundaries. So, first, continental drift, or the theory of plate tectonics. Um, it was discovered by Alfred Wegener, and he proposed the theory that the continents all started as a single supercontinent called Pangaea. And he believed that the continent floated on the oceanic crust, kind of like an iceberg in the ocean. Um, Back in the day, most scientists actually rejected this theory, but it all was one supercontinent and it slowly drifts apart. So if you look at the pictures here, Pangaea in the top left, that's what all the continents looked like millions and millions of years ago. And over time, we've gotten to what we know of as today. But this is over hundreds of millions of years, and you can kind of see the timeline there every 50 or so million years, kind of what it's looked like. Um, some evidence. So in science, we want evidence of this. The continents actually fit together, kind of like a jigsaw puzzle, and you'll see that in an activity we'll do later. Fossils actually match across the ocean. So some fossils that were in South America on the east coast of it were also found on the west coast of Africa. And if you kind of look at South America and Africa, they kind of fit together perfectly. Rock types and mountain ranges, they match across the oceans, and actually climate evidence from glacial deposits. So if you see here, it kind of all fits together perfectly like a puzzle. So if you kind of see how that's all fitting perfectly, that's another big part of evidence. And then we have the distribution of fossils. So we found fossils like in South America and Africa in the same exact areas, Antarctica and Africa. So all of these different areas, we found fossil evidence to help support that. Recap time. What is the evidence that continental drift occurred? And then what is the name of the supercontinent that once existed? All right, so now we'll talk about some seafloor spreading. So seafloor spreading, the ocean moves like a conveyor belt. So you know what a conveyor belt is, just moving constantly. It carries the continents with it. New ocean floor forms along the cracks in the crust as molten material moves up from the mantle. New ocean floor is continually added by the process of seafloor spreading. So the mid-ocean ridge is the most extensive chain of mountains on Earth. So this mid-ocean ridge is 90% of this mountain range lies in the deep ocean, so most of it's underwater. And it wraps around the globe for more than 65,000 kilometers. And it looks like kind of the seam of a baseball. So you can kind of see that and where it wraps around almost the entire Earth. Recap time number 2. What happens when the seafloor spreads? So as the seafloor is spreading, what is occurring? And then what happens at a mid-ocean ridge? So what is a mid-ocean ridge? And you can see that from the previous slides. All right, so the plates that are on Earth, there are major plates, and they are not anchored in place. Remember, they're moving because of the mantle. The asthenosphere is that plastic-like material. So you have the North American plate because North America sits on it. You have the South America plate, South America sits on it. African plate, yeah, Africa sits on it. You kind of get it. Eurasian, because it's Europe and Asia, Eurasian. Okay, so those two continents sit on it. You have the Indian Australian plate, and then the Pacific plate, which you see on the right and left side. Antarctic plate, because Antarctica's on it. Kind of makes sense, right? The continents sit on that plate. So those are the major plates, and we'll do an activity with that next week. Divergent boundaries. So what happens at divergent boundaries? These are boundaries between two plates that are moving apart. So the arrows are going opposite. So diverge, if you're diverging, you're moving apart, and this causes seafloor spreading. So you can see here with these divergent boundaries, when plates pull away from one another, it's a divergent boundary or a spreading zone. So as it spreads, the magma from the mantle comes up, and there you go, it creates a new seafloor. So here you see as a huge mid-Atlantic ridge here. The Eurasian and North American plate, this is a divergent boundary running right through Iceland. So some features of divergent boundaries, you have mid-ocean ridges, which we just showed, rift valleys, and fissure volcanoes. Recap time. What happens at divergent plate boundaries, which we just saw? And then what are the features that are present at divergent plate boundaries? Previous slide will give you that answer. Convergent boundaries. So these are boundaries between two plates that are colliding together. They're converging. Think of the word converge. It means to come together. So they're colliding. There are three types of those convergent boundaries. You have ocean to continent because you have oceanic crust and continental crust. So the ocean plate collides with a less dense continental plate. This creates what's called a subduction zone, where the more dense plate slides under the less dense plate, and volcanoes occur at subduction zones. So oceanic to continental, all right, when those two plates collide, that creates a volcano because of a subduction zone. So let's look at what this looks like here. So subduction is the process which the floor sinks beneath a deep ocean trench. So if you look over here at the picture, you see that the crust is going underneath, the oceanic sliding down underneath the continental, which then is creating the volcano. So another look at that subduction zone, and you look at the deep ocean trench. So that word trench right there, where the ocean and the land meets, so occurs at subduction zones. Those deep ocean trenches do. Deep underwater canyons form where the oceanic crust bends downward. So you have to think about, these are huge sections of earth and it's bending down, so that's going to create a little canyon there in the water, which is called the deep ocean trench. And again, another look at the subduction zone and the volcano that forms up here due to the plate going down underneath. Andes Mountains of South America is another example of that. Recap time. What happens at an ocean to continental convergent boundary? We just talked about that for like 2 minutes. And what is a subduction zone? And what happens at these boundaries? So what occurs? What kind of landform occurs? All right, so now another convergent that we have is oceanic to oceanic. So this happens when two oceanic plates hit. The more dense plate sides underneath, and again, this creates a subduction zone, but creates what we call a trench. Okay, so two oceanic plates coming together. It says converging, they crash. They are both oceanic plates. When both oceanic plates, one slides under the other, often an island group forms at this boundary. So this could be like in this picture here, the island arc. All right, you can kind of see in the middle of the ocean. So where islands are forming in the middle of the ocean, that would be the oceanic to oceanic. You see this in Alaska here. So the Aleutian Islands in Alaska. Recap time. What happens at a convergent ocean to ocean plate boundary and what features occur? All right, now convergent, again, the last one, the third one, continental to continental. This is when two continental plates collide. The plates push against each other, and that creates a mountain range. So you can kind of see here, two continental plates collide together, creates that mountain range there because they're both going to be the same, right? The same type of density. So they'll crash together, creating a convergent boundary, continental to continental mountain range. Earth's highest mountain range is the Himalayas, all right? And that's when the Eurasian and the Indo-Australian plate collides together. And they continue to push together at 5 centimeters a year. That might help you for your project. Recap time. What happens at a continental to continental convergent boundary? And what features are created there? Just talked about it. All right, our last boundary is a transform fault boundary. So a transform boundary, this is when two plates are sliding past each other. They're transforming past each other. They're sliding. And earthquakes happen along these faults. So the famous one we know of, the San Andreas Fault, is in California. So it lies on two boundaries, the North American plate and the Pacific plate. The two plates are sliding past each other. So they're not converging. They're not diverging. They're transforming. They're sliding past each other at a rate of 5 to 6 centimeters a year. Again, help for that project. So their area, they're likely to have rift valleys, earthquakes, and possibly even volcanic action. Recap time, the final one. I know you're so happy to get there. What happens at a transform plate boundary? So what happens at a transform plate boundary? And then what happens as a result of these plates rubbing across each other? So first of all, what's happening? How do you know it's transformed? Okay, and then finally, as a result of these plates rubbing, what kind of things occur?